Hello everyone. This video will be going to talk about dynamic stack implementation in C. So this is what the same concept of earlier program that will implement this stack using arrays. But here is created dynamically. That means we'll use dynamic memory management functions. We'll use dynamic memory management functions which are malloc, calloc, realloc and free. These are the four functions to create memory dynamically. So dynamically means what? If user wanted to insert two elements, then at that time when he wanted to insert two elements, at that particular time only memory will get created. If he wanted to create 5 elements, then memory will get created associated to that. So that is what dynamic. Now, so we have a great difference in between the last program and this program. Last program is what? We defined the array size. If we defined array size 500 and in runtime, if I choose n value to be only 10, other 90 blocks of memory, that means 90 indexes will get wasted, correct? This much of memory loss is there in fixed memory size. So dynamic memory size is not something like that. When I wanted to create a memory for n elements, I'll create memory for n only. I'll not take more than of n. So malloc is to create a block of memory for a single variable. Calloc is for to create a contiguous block of memory for an array type. Realloc is to increase and to decrease. We'll use realloc. Free is not we delete memory, but we'll free the memory to be used by any other variable or any other things. So these are what memory management functions. Now I told you that I'm going to write a program of stack using arrays. So which memory I'll use? I'll use calloc, because calloc is what? Contiguous memory allocation, or we'll have a continuous block of memory to read the elements into the stack. Now look at how I wrote a program. So the first printf scanf header file, and this is what all these are functions I told, right? All these are functions. Look at the parentheses, all these are functions. So I need a standard library file to access these functions. For that I have taken stdlib.h, standard library.h. Now look at this, it is what? A dynamic array. Now I have created a dynamic array. So for that I took a pointer. Now star indicates this asterisk indicates that it is a pointer. So initially this array is pointing to null, and the same variable into top equal to -1, size is equal to 0. That means capacity is equal to 0. I do not created capacity to store a value. I told you this capacity value has to be created through this memory management functions. Now look at how to resize the stack, because capacity is what? 0. Now I have to resize it depending upon the inserting the element. That means when I wanted to push only a single element, how much memory I required? Only one integer memory. That means only 4 bytes of memory is required. So when I wanted to create a memory for an integer value, then I will use malloc. Listen carefully, I'll use malloc. But the reason to use calloc is what? Malloc is it will create a block of memory. That's it. How many variables you have, that many blocks you can create. But calloc is what? It is a contiguous memory location. If one block of memory is created here, the next block will come here, then very next to this, very next to this, very next to this. I need that kind of memory for linear data structure, as I am using array here. Now look at, if stack double equal to null, That means when stack is pointing to null, then I will be creating a memory. So that is what this int star is what? It is a typecasting operator. Typecasting operator. Calloc is what? Memory function. Now, new capacity. According to the new capacity, I have to create a memory. So let's say new capacity is something like a 5. Size of int. Size of int is what? Because I have to create a memory according to the integer. Whatever data type I am using, according to that I have to create. So that means 5 into new capacity is 5. Each variable, each value will take 4 bytes. 5 into 4, total 20 bytes of memory, contiguous memory, a block. A complete 20 bytes of frame will get created. Now, this is what actually, it's a pointer. It returns a pointer. I have to typecast it to the stack, correct? So I took int star. Now, else stack is equal to int star reallog stack new capacity into size of int. What does it mean? The mean of this is when initially I created, when stack equal to null, I am just creating a memory. When stack is full of elements, still I wanted to push the elements, then I have to use reallog. Reallog according to the new capacity. Initial capacity, let's say it is 5. Okay, initial capacity, let's say it is 5. Now new capacity I wanted to take 7. So now capacity value is updated to 7. Now you can only notice this function. That's it. Only this function you have a difference with the previous program. The remaining entire code is as same as with the previous code. So the way how I wrote push function, the way how I wrote pop, everything is same. Look at the push function, the same. Void push int x. I am passing an argument. If top is +1 greater than or equal to capacity. Now I am just inserting the element, resizing the new capacity. Entire code, the logic is same. Only to create a memory, it is different. So this is what pop function. So if top less than 0, stack is underflow, return -1, return stack. So this is what actually push operation. So what will perform in the stack. So every operation, whatever we were discussed before video, the same you can observe. And even you might have noticed that the same functions we were taken, which is push, pop, and peek, or else the display, correct? So now earlier we were seen about this resizing function. So that was the different. So when stack is full, capacity will be doubled. So we were inserted the element at ++ top. What is pop? If stack is empty, it shows the underflow. So display operation is what? Will be displaying all the elements according to the stack. According to this top value, we'll just display the elements from the stack. So this is what the logic of the program. Entire programming is same. Only the size, resize, push operation, you find the difference. Okay. So I'll just make the other video to execute all these two programs, and I'll show you the output with the same code. Thank you.